Okay, let's continue with next subtopic, which is related with the enantiomers. So, basically, we need to understand a few terms before we know how to identify enantiomers. Okay, first is the chirality center. Chirality center is referred to carbon, but not all type of carbon, only sp3 carbon. And recall back to classification of carbon. sp3 hybridized carbon means carbon with 4 single bond. It's only referred to sp3 hybridized carbon. But if we say it is chirality carbon, it must consist 4 different groups. Okay, with these two requirements, sp3 hybridized carbon and 4 different groups, then only we will consider it as chirality center. So enantiomers basically consist of chirality center, and then their mirror image are not superimposable. So basically it's mean tidak bertindih. So besides from has chirality center and then their mirror image are not superimposable, enantiomer also considered as can rotate plane polarized light, and this term is considered as optically active. Okay, just now we have mentioned non-superimposable. What does this mean? Okay, so for example, this is the isomer and this is the mirror image. So both of them are not imposable because here is yellow. So if they are superimposable, here supposedly also yellow color. But now they are different color, so we consider it as non-superimposable. Okay, next we're going to discuss about the polarity meter. This is a device to measure the optical rotation. So basically the rotation will involve clockwise and anti-clockwise. Okay, next we just want to show the mirror image again. So this is a chiral carbon, always will mark with the asterisk. Okay, so this is the mirror image. Okay, so they are mirror image, which is not superimposable. So both of them we call it as enantiomers. So next we are going to do the exercise to identify whether they are enantiomer or no. So look at first compound. The first carbon consists of 4 bonds, but very obvious we can see this carbon is bonded to 3 hydrogen, which are similar. So this is not chiral carbon. And then the second carbon bonded to hydrogen, OH, COOH, and CH3. So the second carbon is chiral carbon. Okay, so if now we focus on the third carbon, okay, the third carbon is COOH. So when we expand this, it will become C double bond O, OH. So this carbon cannot be the chiral carbon because it is not sp3 hybridized. Okay, next one we go to the B. So this carbon definitely is not a chiral carbon because of 3 similar group. So we move to the next one, second carbon here. Okay, this carbon also is not chiral carbon because one group is hydrogen, second group is CHCl2, and the third and fourth group are CH3. So that means they have 2 groups which are similar. So this carbon also is not chirality center. Now we move forward to the third carbon here. This carbon, the third carbon here, consists of 1 hydrogen, again 2 Cl, and another one is CH3. So basically they have 3 different groups, not 4 different groups. So again, this compound cannot show chirality center, and hence no enantiomers can be drawn. Okay, we proceed to exercise 6, which is the chiral carbon or chiral center. So first carbon, no, because consists of 3 groups similar. Second carbon also no, 2 groups similar. Third carbon, yes, one is hydrogen, another one is chlorine, and then the third group is OH. The fourth group is CH2, CH3. So this is the chiral carbon. How about the second compound? So the carbon in benzene ring all are sp2 carbon, so we no need to consider. So this carbon have 4 groups. One is hydrogen, second CH3, third CN, and the fourth is the benzene ring. So for both compound here, they have the chiral center. So next we need to draw pairs of enantiomers. Okay, so if we want to draw the pair of enantiomer, we have to draw in 3D. For example, the first compound, CH, Cl, OH, and then bonded to CH2, CH3. So don't forget, this is the mirror, and then the mirror image at the top here will be the hydrogen. From here is the Cl, and then here will be the hydroxyl group, and the last one will be the CH2, CH3. So most important, we need to label these two as enantiomers. And this one here basically is referred as mirror. So you can label they are mirror. Okay, that's all for enantiomers.